So today we are looking at Buffon's needle problem. And before I move ahead with the solution, I will try to explain the problem once again. So problem is you have an infinite plane which is divided into vertical strips, each of length h. The plane extends towards infinity in all the direction. Now you have a small stick of length L. Now assumption here is L is less than h, and problem is, what if L falls in the plane? What is the probability that it will lie on one of the interface? But so to start looking at the problem, if you have like infinite number of strips, so you can say that one strip corresponds to one interface. Okay, now probability is of finding probability of the needle falling on the interface, right? So now let's just look at one interface. Now what are the first we look at, okay, the needle falls just straight, so there's no angle involved right now. So in this case, what is the possibility? So either you can have like the very end of right end of the needle touching the interface, or you can have the beginning end of the needle touching the interface. So now just think about the starting point. The starting point can be here to here, right, which is exactly the L distance. So probability is starting point can be in the length L, whereas the total possible length is h. So this is the probability. But now if you assume that you are at an angle, let's say theta, then this effective L reduces. So p theta is actually nothing but L cos theta by h, right? And probability of picking one theta is d theta by 2 pi. And if you want to find total probability of falling on interface, then you have to integrate this from 0 to 2 pi. Cos theta by h d theta by 2 pi. Now what we do here is we just divide this into 4 interval of 0 to pi by 2. We take L by 2 pi h outside, so it's now 0 pi by 2 cos theta d theta. This term is 1. So this term is 1, and what you are left with is just 4L by 2 pi h, which is, if you just simplify it, is 2L by pi h. So this is your probability.